Greetings to everyone. I'm Dr. R. Chitra, working as Assistant Professor in the Department of Physics, GVG Vishalakshi College for Women, Udumal PET. Today I am discussing the topic on laser introduction and the process involved in laser action. Let me share a PPT to give a more clear idea. So what is laser? It is acronym of light amplification by stimulated emission of radiation. So laser is nothing but a light radiation and we are amplifying the light radiation by the process stimulated emission. So here let's see what is incoherent and coherent. So these are the new terminologies that we come across right now, but this is more ideal to get a clarity over this to discuss the topic on laser. So incoherent. So here I have taken sun. It is a polychromatic. So see radiations are in all the directions. So the light radiation coming out from the sun is in different phases and or in different time period. So the ways that light radiation waves are coming from the sun is incoherent. So you can come to very well know about this incoherent by seeing this picture. So see here, this is a laser light and all the radiation, that is light radiation coming from the laser is a coherent and they are in phase with each other at any time. So this is coherence. So I hope, and one more thing I want to insist right now is the light radiation from the sun is incoherent as well as it is in all the direction. But you see here, the laser light is directional. So it is, you just imagine if the sun radiation is not in all the direction, it is it only one particular direction and it falls over the one particular spot, then can you imagine the temperature that will occur at that particular spot? So this is the thing, when the laser light falls at a particular spot, so the laser light is highly intense and since it is directional, the laser light is highly intense. But here, the sunlight falls on, it spreads in all the directions. So it is not intense and it is not directional and it is not coherent. So the laser light here falls at a particular spot and it is directional. So since it is directional, it is intense and it is coherent too. So this is nothing but the thing of differences between ordinary light and a laser light. So next, let us see what is the basic principle in laser action. So the three processes that we should know, they are stimulated absorption, spontaneous emission, and stimulated emission. So before getting into this, let me go to the detailed description of these three processes, and then we will come to know about the thing. So first one is what is stimulated absorption. This is nothing but an energy level diagram. So this E1 just denotes the ground state energy level and this E2 denotes the excited state energy level. So stimulated means it is not a spontaneous process. It is not occurring by its own. So we are going to stimulate, we are going to induce. So here absorption. So let us see what is that absorption. So this process is not natural. This is going to be the stimulated one. So see, this is the energy level diagram. So that atom, you just imagine that atom is in the ground state. So what is this actually? It is that already I said like that this process is not a natural one. This is an induced one, stimulated one. So we are here using photon of light, that is light as an external source. So light energy we are going to give to this atom and we are going to stimulate this atom to go to the excited state, that is the state E2, by absorbing this energy. So you just imagine this atom is having some 10 electron volt of energy. So this state is 15 electron volt of energy, this energy level. So this 10 electron volt energy atom cannot go to this state. It requires additional amount of 5 electron volt. So that additional amount of 5 electron volt of energy that we are supplying by its external light energy. So the photon of light energy that falls over this atom. So this atom absorbs that extra energy, that is requires extra energy from this photon, and this atom goes to the excited state. So initially the atom is in the ground state. So we are stimulating that atom to go to the excited state by the process of giving external energy by means of photon. So the now atom goes to the excited state. So this process is known as absorption, and this is a stimulated process. Atom cannot go by its own. So we are stimulating the atom to go to the excited state. So this process is stimulated absorption. The next one, let us see what is spontaneous emission. So by the process of stimulated absorption, we have made the atom to go to the excited state. So the now atom is in the excited state. You just imagine like. And that suppose you just imagine that we are in a very happy state and you have achieved something. So you will be in excited state, right? So but you cannot be in that excited state for a very long period. After some period of time, yeah, out of all celebrations, that you have to come to the original state, that is ground state. So here that atom is in the excited state. It cannot be in the excited state for a very long period of time. So spontaneously, that is naturally by its own, the atom will come to the ground state. So and one more thing, the lifetime of atom in the excited state is very minimal. So everything in the nature just tries to secure its life. So that this atom will also try to secure its life. So it will spontaneously come to the ground state. So while coming to the ground state, it possesses now 15 electron volt of energy, as I said as example there. So this releases this extra 5 electron volt of energy as a light energy. So while coming to the ground state, the atom emits that extra energy as a light energy. Now the atom is in the ground state. So this atom, in order to secure its life, it spontaneously comes to the ground state. So while coming to the ground state, it releases one photon of energy, h nu. So this process is known as spontaneous emission process. Here that absorption means by absorbing energy, the atom goes to the excited state. So from excited to ground state, that emission happens, that is that light energy is emitted. So this process is known as spontaneous emission process. So the next process is stimulated emission. So now that atom is in the previous case, as by means of stimulated absorption, we have made the atom in the excited state. So as I said earlier, this atom will try to comes to the ground state by emitting one photon of energy. At this process is nothing but a spontaneous emission process. But before this process to start, what we have to do that we have to supply this one photon of energy from outside to make that atom to come to the ground state. So this atom will absorb this photon of energy h nu, and then while coming to the ground state, it releases two photons. That is, for this atom, it automatically spontaneously comes to the ground state. But before the process starts, we have to stimulate the atom to come to the ground state by supplying external energy, that is one photon of energy h nu. So by absorbing this energy, this atom comes to the ground state. While coming to the ground state, it emits two photon of energy. In additional bonus, these two photons are in same direction and they are coherent with each other. So that's the thing we require for laser action. So that is coherence. So that coherence is here. That coherence is be attained, as well as we have attained the directionality also. If we attain directionality, already we have discussed that intensity will be there. So for one photon, we have just obtained two photons. So if we supply 2 photons per atom, then how many number of photons as a result? We will get 4 photons. So that is the photons. Light energy is also amplified, and they have made it in the directional manner, and that intensity is also observed, and the released photons are in coherent with each other. So this is the process expected that to happen in laser. So if this process happens, then we can attain laser light. So now let us summarize the characteristics of laser light. It is highly directional. Since it is directional, it is intense. And one more thing, the laser light is monochromatic. It is a single wavelength of light, unlike sunlight. It is coherent. Waves are in phase spatially as well as in temporally. So what is laser finally? A laser is a device that emits a narrow, intense beam of coherent light through the process of stimulated emission. So summary, lasers are powerful tools that utilize the principle of stimulated emission, and their unique properties make them indispensable for science, technology and medicinal applications. So the understanding the fundamentals in laser will explore many more optical technologies. Uh, Thank you.